Okay, so we just learned how to find slope from a graph. As a quick review, we went from our point farthest to the left up farthest to the right, and we did our rise over our run. So as you see the points 4, 2, 6, 8, we rose 1, 2, 3, 4, 5, 6, and we ran 1, 2. Okay, so you can tell from this graph that we rose 6, we ran 2, and which means when we reduce, our slope was 3, right? So what I want to show you today is that, we don't always have a handy piece of graph paper. So if I need to find the slope from 2 points that are given, we're going to use a formula today and use some algebra to kind of figure that out. And so before I show you that formula, I want to just kind of point something out here. When I went up and I rose, that was the change in my vertical axis, which is my y's, which is the 8 and the 2. So if you can kind of see where the 6 comes from, it comes from the 8 minus the 2, right? The difference in my y coordinates. And then as I went over and I did my horizontal x distance, that was going from the 6 to the 4 or the 4 to the 6, and that's where the 2 came from. And so we're going to kind of use that information, and I'm going to show you how to use a formula to have you figure out the slope of the line, okay? So we're talking about slope from 2 points, and the first point we're going to use as an example is the one we just did, 4, 2, and 6, 8. We know the slope of this line was 3 over 1, or just 3. Now let me prove that to you. So usually when you see 2 points, they're going to be actually next to each other like this, but I'm going to have you do something called stack and subtract. Okay, so the stack and subtract is going to be exactly what it sounds like. I want you to stack these 2 points on top of each other. So the 4, 2 and the 6, 8, so you are lining up your x values and lining up your y's, and you're literally going to do a formula where you're going to find, and I want to put this in a nice bright color here so you understand what we're looking for. The stack and subtract are the y values minus each other and divided by the x values minus each other. This is our change in our vertical distance, which is our rise, and this is the change in our horizontal distance, which is our run, okay? And so let's see what that looks like. That looks like something like this. We're going to do 2 arrows with a line right in the middle, and that's how we're going to set up every one of these problems. And so as I do this here, I'm literally just taking the 2 and subtracting the 8, and the 4 and subtracting a 6. And then I'm going to continue to work over just doing these problems. And if you remember, this is a positive 2 plus a negative 8, or just 2 minus 8, which gives you negative 6. And then 4 minus 6, or 4 plus a negative 6 gives you 2. And we know a negative divided by a negative is a positive, and that's how we got 3. Now I want to show you real quick that if I would have chose to stack them the other way, and there's really no way of knowing, which if it matters or not. So if I were to stack the other one on top, just going to show you real quick, I would do 8 minus 2 and 6 minus 4, which is kind of nicer just because you don't have any negatives to worry about. But 8 minus 2, there's your 6 and there's your 2. So you get 3 either way. So that's example 1. And I want to do a couple more because they're going to get a little trickier, okay? So the next one I want to do is take 0.1, 5, and I'm going to stack them right from the beginning, 3, 4. And so I'm going to start out kind of with these 2 arrows in my line. And you know what? You could even use some highlighters and say, okay, the first subtraction problem I'm going to do is going to go here. That's my first one. The second subtraction problem that I want to do is going to be my x's minus each other. That's the most important thing to keep in mind. Whenever you're talking slope and rate of change, it's always the change in your y's divided by the change in your x. So I'm literally just going to write 5 minus 4, 1 minus 3. And that's going to give me, obviously, 1 on top. 1 plus negative 3, and my slope is a negative 1/2. I would get the exact same thing if I would have stacked them the other way, okay? Now, this is going to be a little tricky example, so let's take a look at number 3, because something's going to happen here that I know might throw you guys off. So I have 7, 5, and negative 4 comma 7. So as I'm looking at this, I start to do my, bring this down just to kind of keep it organized for you. I'm going and I'm doing my y's minus each other, and that's 5 minus 7. And then I have my negative 7 minus, because what's important to know is that the formula for all of these has been a minus, right? And what I'm going to do is take this 4, this 7, and subtract a negative 4 from it. And so what we learned when first of all, we're going to simplify this to get negative 2. What we learned about our integer rules is we don't subtract, we add in the opposite. This is like taking away a fee. And if you take away a fee, that's like giving it that money back, right? And so as I am working this out, I get negative 2 over, forgot the negative here, sorry. And that's going to give me a negative 3. And then I take a look at this. Please don't leave your answer that way, because I need to know that you know that a negative divided by a negative is a positive, okay? And so the slope of this line is 2/3, which means I would rise up 2 over 3, okay? Let's do a couple more examples, because a couple other crazy things are going to happen, and I really need you to be comfortable with that. So let's take a look at negative 5 rather, sorry, and 6, negative 8. Okay, so I'm gonna stack them. I'm going to set it up and get it ready. I'm gonna take this negative 5, and actually, if you get confused, this is a really good way to look at it. The formula requires you to find the difference, which means that's a negative. And it's almost like literally just put this y value in here and this one in here. And then the 2 minus the 6, okay? And then keeping in mind that sometimes that will change to a plus, not all the time. And so this is gonna stay minus because I'm not subtracting a negative, and this is negative 4. And when you do these problems, just kind of work your way across, right? So this is 5 plus negative 8, negative 5 plus 8 is 3, divided by negative 4, and that is your slope. It can't be reduced, and so there you go. All right, these last two examples I want to talk about. So this is example number 5. So example number 5 says, take 3 comma 2 and negative 1 comma 2, and something weird's going to happen. So I'm going to stack and subtract, and I'm already going to see that both of my y coordinates are the same. So I'm going to have a 2 minus 2, and at this point, you really have all the information you need. You don't even really need to see what the denominator is. I'll show you why in a minute, but let's just do it. Let's just do 3 minus negative 1, and if those of you who are kind of picking up on this saying, oh, hey, I know that I'm about to subtract a negative, so I'm just going to make it a plus right away. Just be careful with that, because sometimes people start making pluses and they're not supposed to be. So anyways, it doesn't matter, because 2 minus 2 is 0. And what we learned, when we take something, 0 divided by any number is 0. And so if a line has a slope of 0, if you remember from what we talked about before, if I were to plot point 3 comma 2 and point negative 1 comma 2, my vertical distance is the same. So my rise, my distance above my axis here is 2, and it doesn't matter. So, and if you remember, this is a 0 slope. So what you remember when you have the 0 on top of a fraction in the numerator, it's going to be a horizontal line, okay? And I really want you to reduce that 0 over 4. Don't just leave it 0 over 4, because I won't know if you are thinking that it's 0, if it's 4, or whatever, okay? Let's take a look at this last special case in example number 6. And let's do point negative 8 comma 0, and let's stack that over negative 8 comma 5, okay? And so as I'm looking at this one, I go to subtract my y values, because that's the change in my vertical distance, and that's 0 minus 5. And then I have my negative 8 minus a negative 8, which go ahead and put a plus if you're okay with that, which this time these are going to cancel out. That's going to give me 0 in my denominator, which means it doesn't really matter what's in my numerator, but let's just finish it. Now, a lot of you think, and when you see a 0, you might think that the answer is 0. It's not. When you see negative 5, you might think the answer is negative 5. The answer to this problem is neither negative 5 nor 0. And what this means is try to divide a number by 0 and you just can't do it. Meaning division by 0 does not exist in math. It's called undefined because it doesn't even make sense. You can't divide something by 0. So what I need you to know is that when you get 0 in your numerator for a fraction, that actually does simplify to 0, which means we have a horizontal line with a 0 slope. Let's plot these points real quick and see what this would give us. If I plot point -8, 0, meaning don't rise any, -8, 5, then you see that I actually have a vertical line. And if you remember from the videos we talked about before with the 4 types of slope, a vertical line, you should have seen this word before, a vertical line has an undefined slope. And so this kind of checks out. So what we are going to be working on next is making sure we know how to find the slope of 2 points even when we aren't given the graph.